Hello everyone. In today's video, we will be covering the entire trigonometric chapter, the meaning of trigonometry, the basics of right angle triangles, what are trigonometric ratios and trigonometric ratios of certain angles. We'll also be seeing the trigonometric ratios of complementary angles, and finally, we will understand what are trigonometric identities. So friends, I hope that this video will help you better understand trigonometric chapter. So let's start. So what do we mean by trigonometry? So friends, this word trigonometry has come from three different Greek words: tri, gon and metron. Okay, now tri means three. Well, you have come across tri before, triangle, triplets. So they all mean three. Gon means sides in Greek. So you have polygon, hexagon, that means sides, okay? And metron means measurement. Metron, as in you have heard of meter, metrics, that means measurement. So trigon, metron together gives you trigonometry. So trigonometry is nothing but the measurement of sides of triangles. So the entire chapter is based on triangles, more specifically right angle triangles. So we will be studying how the sides and the angles of a right angle triangle are related to one another. Now friends, before we start with trigonometry, let's quickly go through the basics of right angle triangle, because trigonometry is all about right angle triangles. So if this concept is clear for you, then trigonometry will be very easy. So here is a right angle triangle, ABC. Can you tell me where is the 90 degrees? Yes, this is the 90 degrees. So angle B is going to be 90 degrees. So friends, do you recall that in a triangle, you have something called as the angle sum property? Yes, what does it say? It says that the sum of the angles in a triangle will always be 180 degree. Now there are three angles in a triangle. So angle A plus B plus C will always be 180 degrees. Now I already know that angle B is 90. So let me put that over here. Let's see what we end up with, okay? So we get angle A plus angle C as 90 degrees. Now this is very, very important because it tells you that the sum of the other two angles is 90 degrees. So if one angle is 90, the other two angles when you add up will also be 90. Now this also means that each of these angles, angle A and angle C, each of them definitely have to be less than 90, friends. Because see, even if one of them is 90 or more than 90, how can the sum be equal to 90? That's not possible, right? It means that each of these two angles, see, angle A and angle C, have to be acute angles. That is very, very important. So remember, in a right angle triangle, one angle will be 90 and the other two angles will always be acute angles. So as far as angles are concerned, this is what you need to know. Now let's come to the sides. Okay, so which is the most famous side in a right angle triangle? Well, it's the hypotenuse. I'm sure you all know that. Where is the hypotenuse? Can you spot it? Yes, it is always the side which is opposite to the 90 degrees. Here is my 90 degrees and the side opposite to that. That is, you have to see which side doesn't touch this angle. So this angle is made up of these two arms. So these two sides will not be opposite to this angle. It is this side which will be opposite. So this is the hypotenuse, friends. Okay. Always remember, hypotenuse is the largest side in any right angle triangle. So this is my hypotenuse. The other two sides are known as the perpendicular and the base. So I can either call this as the perpendicular and this is the base, or the other way around also. It really doesn't matter at this stage. Okay, so this is hypotenuse, perpendicular and base. And do you also recall one other important theorem? Yes, the Pythagoras theorem. The spelling is also very tricky. Pythagoras theorem, what does it state? It states that the square of the hypotenuse, okay, which is my hypotenuse over here, AC square. The square of the hypotenuse is always equal to the sum of the squares of the other two sides, that is AB square plus BC square. This is very significant theorem, friends. We will be using it extensively in trigonometry. So remember the Pythagoras theorem. Also, one last important thing in right angle triangle is about the relation between angles and sides. So let me take this angle A, friends. Okay, just consider angle A. Can you tell me which is the side that is opposite to angle A? The side which is opposite to angle A will be this side, see, BC, because it is not touching angle A. So can I say that the opposite side for angle A is BC, right? What will be the adjacent side for angle A? Now, adjacent side means the side should be next to the angle. So I can see two sides, see, AB and AC, both are adjacent to angle A. But this side AC is already given the name hypotenuse, right? So why to give it another name adjacent? It is already adjacent also, but we have given it a special name hypotenuse. So we will call this other side AB, which is also adjacent to angle A, as the adjacent side. Okay, adjacent means next to it. Okay, that is the meaning of the word adjacent. So here the adjacent side is AB for angle A. Okay friends, I hope this is clear. Now let's come to angle C. And of course, for angle A, where is the hypotenuse? That is never going to change. The hypotenuse will always be AC only. Now coming to angle C, which is the hypotenuse? Let's finish off that first. Again, the hypotenuse doesn't change. It will be AC only, right? Where is my opposite side for angle C? See, this is angle C. The opposite side is going to be AB. Did you see that, friends? So here in angle A, the opposite side is BC. Here the opposite side is AB. So when you change the angle, the opposite side also changes. Okay. So the opposite side is AB, and where is the adjacent side for angle C? Okay, this BC. See? So that also has changed. So as your angle changes, the side name also changes. So with this much knowledge, let's go to trigonometric ratios. So what do you mean by ratio? So ratio is nothing but the division of two quantities which have the same units. Now we are going to talk about trigonometric ratios. Let's consider this right angle triangle ABC. Now you know that the hypotenuse of this triangle will always be this side AC. It's never going to change. But what about the opposite side and the adjacent side? Well, that will change if you change the angle. So let me fix the angle. Let me fix my angle as angle A. So can you tell me what will be the opposite side now? Yes, the BC will be the opposite side here. Okay. And what will be the adjacent side? Yes, AB will be the adjacent side. So I'm fixing the angle. So therefore I'm also naming the opposite side and the adjacent side. Now friends, let's start taking ratios of different sides of the triangle. Okay, let me first go for the combination of opposite side divided by the hypotenuse. Okay, what am I doing? I'm taking the ratio of the length of the opposite side to the length of the hypotenuse. So remember, this is for angle A. So what is the opposite side for angle A? It is BC. And what is the hypotenuse? It is AC. Friends, this is the first trigonometric ratio. And just to give it a name, mathematicians have given this the name as sine of which angle it is. We are considering angle A. So it will be called sine of angle A. Now every time if we write sine of angle A, it will become very lengthy. So they have also shortened it. They have called it as SIN. Okay, this is also pronounced as sine. This is not sin. So sine of angle A, they have simply written it as A. Okay, that's it. So sine A is the opposite side upon the hypotenuse, friends. This is a very important trigonometric ratio. Okay, so I hope you understood this. Now, let's come to the next trigonometric ratio. Now, I have already covered this combination. Which is the other combination? Let me try adjacent side to the hypotenuse. Okay, this will give me the next trigonometric ratio. That's it. So for A, what will be the adjacent side? It's going to be AB. The hypotenuse will remain as AC. And this particular ratio is known as cosine of angle A. What is it known as? Cosine of angle A. Again, the shortened form that we always use is cos A. Simply cos A. Okay. So it is the adjacent side by hypotenuse. Now, two combinations are already over. Let's go for the third combination. Let me now try opposite side length divided by the adjacent side. Okay, for the same angle A. So what will be the opposite side? Yes, it will be BC. The adjacent side will be AB. And this third ratio that we have got is known as tangent of angle A, shortened as tan A. Okay friends, so tan A is nothing but the opposite side upon adjacent side. So three ratios have been covered. Now just if you observe a little more minutely, you will see that when I divide sine A by cos A, let me just do that. Okay, sine A is what? Opposite upon hypotenuse, that is BC by AC. Okay, divided by, what is cos A? AB by AC. What do I do now? You know that, right? You have to take the reciprocal. So my AC comes up, AB comes down, AC and AC gets cancelled. What am I left with? BC by AB. See, it's the same as this. That's why we have an important relation that tan A is equal to sine A by cos A, friends. So it's also very important, this relation, interrelation of the trigonometric ratios. So you have sine A, you have cos A, tan A, and then also a relation that tan A is sine A upon cos A. Now another combination that I can have is, instead of writing opposite upon hypotenuse, I can also write hypotenuse by opposite side, right? This will give me a different ratio. This is known as cosec A, okay? So this is cosec A equals to hypotenuse upon opposite side. So friends, you can see that it's just the reciprocal of sine A. So I can also write that cosec A is 1 upon sine A. See how they are interlinked. We have already got the tan A is sine A by cos A. Now we have another relation, cosec A is 1 by sine A. Now let me come for the next combination. Here I am going to take hypotenuse divided by the adjacent side. Okay. See, what is this called? This is again given a new name. It is known as sec A. Now, this is the full form is secant of angle A, friends. So again, it's shortened to sec A. Now, as you can see, it's just the reciprocal of cos A. Did you observe that? This is adjacent upon hypotenuse. This is hypotenuse upon adjacent. So I can write that secant or sec A is 1 upon cos A. This is another result. Finally, the only combination that is remaining is adjacent side, the ratio of the adjacent side by the opposite side. Yes, this is known as cotangent. This is known as cotangent of angle A and shortened as cot A. And again, you will see it's just the reciprocal of tan A. So I can write cot A as 1 upon tan A, friends. Okay. See, I've got so many results as we are defining the different trigonometric ratios. So friends, based on whatever we have studied, let's do a question and see if we are able to apply all the concepts that we have learned till now. So the question is, if cot theta is 7 by 8, evaluate 1 plus sine theta times 1 minus sine theta divided by 1 plus cos theta times 1 minus cos theta. Okay, so how do we proceed? So since this is all about trigonometry, friends, the first thing you need to do, the very first thing is draw a diagram. So in trigonometry, drawing diagrams will really help you understand the question. So please friends, don't shy away from drawing the diagrams. Make sure to make a small diagram. Okay, so this is my 90 degrees. Okay, let me name the sides also. Now theta. Now what do you mean by theta? Theta, friends, is just a Greek symbol. So instead of writing A, sometimes in the question you will get theta or alpha, beta, gamma. There are so many symbols. So no need to get confused. Theta is just a way of telling the angle. So I can call this as theta. Always friends, go for the base angle, okay? Because if you take the angle at the top, sometimes we get confused which is the opposite side, which is the adjacent side. So always go for the base angle when you're trying to solve problems. So I'm going to take this as theta, okay? Now cot theta is 7 by 8. Now let us recall, what is cot theta? Do you remember? Yes? So we have defined cot theta as adjacent side by opposite side. So for this theta, where is the adjacent side? This is the adjacent side. See, BC. So let me first write what is cot theta. It is adjacent side by opposite side. That is BC, which is found out. Then what is the opposite side for theta? Yes, it is going to be AB. Okay, friends. So cot theta is BC by AB. But they have given cot theta as 7 by 8. That means I can write 7 by 8 as BC by AB. Now the ratio of these two sides is given as 7 by 8. So does this mean that BC becomes 7 and AB becomes 8? Not at all, friends. Don't make the mistake of writing BC as 7 and AB as 8. This is completely wrong. What you need to do is, you need to take BC as 7x and AB as 8x. So there must be some common factor x, which when multiplied will give you the original sides back. Right? So if this was 7x and 8x, when you take the ratio, the x and x will get cancelled and you will get 7 by 8. So the original side, the original length, let it be 7x and 8x. So BC is 7x and AB is 8x. Okay. Now this is done, but we need to find sine and cos, friends. So again, what is sine? What is cos? Let us recall. Sine is opposite side upon hypotenuse. Cos is adjacent upon hypotenuse. Okay. So let me write that down. Sine theta is opposite side upon hypotenuse. Now for theta, the opposite side is AB, hypotenuse is AC. Right? Similarly, what is cos theta? The adjacent side upon hypotenuse. That is BC divided by hypotenuse will be AC. Now, which is the unknown over here, friends? Can you spot? We know what is AB and BC as 8x and 7x, but we still don't know what is the hypotenuse. So our main target now is to find the hypotenuse. Once we find the hypotenuse, you can find sine theta, cos theta, and then you can easily evaluate this expression. Now, how do we find the hypotenuse? Can you recall? Yes, the Pythagoras theorem will come to help you. What is the Pythagoras theorem state? The square of the hypotenuse, that is AC square, is equal to AB square plus BC square. Friends, always if it's a theory paper, make sure to write the reasoning, okay? Whatever theorem or property you're using, make sure to write its name in the bracket. Now, AC square, again we don't know. What is AB square? It is 8x the whole square. Remember to put the bracket, otherwise your answer will be incorrect. What is BC? 7x the whole square. Let me now bring the square inside. I'll get 64x square plus 49x square. So this means that AC square is going to be 113x square, friends. So what does this mean? AC is nothing but square root of 113x square. Now, because of the square, what happens is that the root and the square negates and you will get square root of 113 and x comes outside the square root. Just take care of this fact, friends. The x is not inside the square root, it's outside now. Now we know the hypotenuse. So now that we know AC, let's quickly find out what is sine theta and cos theta. So sine theta, if you remember, where is it? Yes, over here, AB by AC. So AB is 8x and AC is going to be, you can even write the x before, just to avoid the confusion of whether x is inside the root or not. this way, and cos theta will be 7x. See, it is BC. So 7x divided by the hypotenuse, which is x root 113. So the x and x gets cancelled, friends. So this is sine theta and cos theta. Now we need to find out this expression. So it is 1 plus sine theta, that is 1 plus 8 by root of 113 bracket 1 minus sine theta, like this. Let's quickly substitute the value of sine theta and cos theta. This is going to be cos theta value. Okay. So friends, now we have to take the LCM, because as you can see, the denominators are not the same. So when I take the LCM, I will get 113 over here. This is what we get. Here also the same 113 will be the LCM. You will get something like this. Do not get confused by these huge square root, friends. At the end, everything will work out fine. As long as the method is correct, you need to be confident. Okay, so this is how the LCM part will work out. Okay, now if you see, this is common everywhere, friends. See, this root of 113 into root of 113. So I'll get only 113. So into 113 minus 8. So square root of 113 into square root of 113, I'll get only 113 divided by, this will become, I'll put a huge bracket over here to avoid confusion. And I will get something like this. Again, the same story over here, I'll get 113. Okay, so till here I hope it's fine. Now what we need to do is, we can take the reciprocal, friends. See, so I will get 113 plus 8 into square root of 113 minus 8 divided by 113. When I reciprocate, 113 comes to the numerator, and in the denominator, this is what I get. Okay, so 113 gets cancelled. Now friends, I'm sure you would have identified the pattern over here. See, this is a plus b into a minus b. Here also, a plus b into a minus b. Do you recall that identity? Yes, it is nothing but a square minus b square. So I'm going to use this identity over here. So I'll get 113 square root the whole square minus 8 square. So even in trigonometry, you have to remember the other concepts also that we have learned. So this is nothing but 113 minus 8 square is 64 divided by 113 minus 7 square is 49. So 113 minus 64 is 49, and this will give me 64. So friends, the entire expression that we had to find, evaluate, 1 minus sine theta, 1 plus sine theta. So the value of this expression is going to be 49 by 64. So this is how you need to solve these type of questions. Okay. Now friends, we come to the next part of trigonometry, which is learning the trigonometric ratios of certain angles. Now trigonometric ratios exist for all type of angles, friends. Okay. But we are expected to remember and memorize the trigonometric ratios of these 5 angles in particular: 0 degrees, 30, 45 degrees, 60 and 90 degrees. Okay, so let's quickly see what are these trigonometric ratios. Now sine of 0 is 0. Okay, sine 30 is half, sine 45 is 1 by root 2, sine 60 is root 3 by 2, and sine 90 is 1. So friends, as you can see, as your angle increases, the sine ratio also increases till it reaches 90 degrees. Did you see that? Now for cos, it's just the opposite, friends. Okay, so cos 0 will be 1. You might as well copy this in the reverse order. Cos 30 is root 3 by 2. Cos 45 is 1 by root 2. Cos 60 is half, and cos 90 will be 0. See, it's just the reverse of the sign. So did you observe that as your angle increases, the cos ratio actually decreases from 1 to 0. Okay. Now we come to tan. Do you recall what is tan? Yes, it is sine by cos. So you just have to divide sine by cos and you'll get the tan ratio for that particular angle. So sine by cos over here, so tan 0 will be 0. Here for tan 30, you just have to do half divided by root 3 by 2. You'll get 1 by root 3. Here it's the same value. So tan 45 is 1. It's the easiest, one of the easiest ratios to remember. Tan 60 is root 3. Now tan 90, 1 divided by 0. Friends, we don't know what is 1 divided by 0. That's why we write it as undefined. Okay. Always remember, anything divided by 0, we don't know what is the answer. So we'll call it as undefined. Now, these three are very, very important, friends. Now, after these comes cosec, sec and cot ratios. Now, once you remember these ratios, it's very easy to derive the remaining three ratios also. You know why? Because cosec is nothing but 1 upon sine. Yes, do you recall? Sec is 1 upon cos and cot is 1 upon tan. So, you just need to reciprocate the sine value. See over here, sine 0 is 0. So, cosec will be what? 1 by 0, which is undefined. See? Now, what about 30? You just have to reciprocate half. So, you'll get 2. So, cosec 30 is 2. Cosec 45 will be, again, 1 by root 2. Take the reciprocal. You'll get square root of 2. Cosec 60 will be 2 by root 3. And cosec 90 will be 1. See, friends? So, even if you don't remember cosec of an angle, it is still fine. Because if you remember sine of that angle, just take the reciprocal, you'll get the cosec. Okay, let us quickly do sec also. Remember, it's 1 by cos. So, all your eyes should be on the cos row. So, sec 0 will be 1. Sec 30 will be how much? 2 by root 3. Sec 45 will be root 2. Sec 60 will be 2. And sec 90 will be, see, it will be 1 by 0, which is undefined. Okay, now let's also do the cot table. It's 1 upon tan. So again, this is 1 upon 0, which is undefined. Okay, cot of 30. So let me come to tan of 30 and take the reciprocal. It will be root 3. This will be 1 and this will be 1 by root 3. And here cot of 90 will be 0, friends. Okay. So this is a very important table. Make sure to remember these ratios, especially sine, cos and tan, because cosec, sec and cot you can always get from these three ratios. So now let's go ahead and try one question which is based on these values. Okay. So the question is, evaluate this expression. So if you see, all these angles are the standard angles whose ratios we have defined over here. So this question is all about remembering the ratios and substituting them properly in this expression. So let's start substituting. You will get 5 into cos 60. So what is cos 60, friends? It's going to be half. So I'm going to take the square. So initially you may have to refer to the table, but gradually try to memorize it, friends. Okay. Half the whole square plus 4 into sec 30. So if you want, let's see, where is sec 30? Over here. It's 2 by root 3. Okay. So 2 by root 3 the whole square minus what is tan 45? It's 1 square divided by sine 30 is again going to be half square plus cos 30 is root 3 by 2 the whole square. Okay, friends. So now slowly let's open up the squares. You'll get 1 by 4 plus 4 into, this is 4 by 3. Remember, root 3 into root 3 will give you 3 minus 1 over here. This will become 1 by 4 plus 3 by 4. Okay. Now 5 into 1 by 4, 5 by 4 plus 16 by 3 minus 1. Now the denominators are the same. So I can add the numerator, friends. So I'll get 4 by 4. So here in the numerator, all the denominators are different. So I need to take the LCM, which will be 12. So I will get 5 into 3, 15 plus 3 4s are. So 16 4s are, I'm going to get as 64 minus 12. Okay. Divided by 4 and 4 will get cancelled. I'll get 1. So this will be nothing but 79 minus 12 by 12. Now 79 minus 12 will give you 67 by 12. So friends, this is the answer for the expression. This is how you have to evaluate this expression. Now friends, the next topic is trigonometric ratios of complementary angles. Now if you remember, initially when we were studying about the basics of right angle triangles, we had concluded that as angle B is 90 degrees, angle A plus angle C is 90 degrees. Then we went ahead and said that angle A and angle C are acute angles. Now, since these two angles when added give 90 degrees, do you recall what are these angles known as? There is a special name given to that. Yes, these are known as complementary angles. So angles which when added give you 90 degrees are known as complementary angles. So in a right angle triangle, you actually have angle A and angle C as complementary angles. Now let's discuss how do the ratios of these complementary angles behave. Now for example, let us write sine of A. What will be the formula, friends? It is opposite upon hypotenuse. Okay, so the opposite side for angle A will be BC divided by the hypotenuse. Remember, that will always be constant. It will be AC. Okay, now let me also write the other ratios. Cos A will be the adjacent side, AB upon AC. Tan A will be, yes, it will be the opposite upon the adjacent. Okay. Cosec A will be, can you guess? It will be the hypotenuse upon the opposite. I'm just taking the reverse. Sec A will be AC by AB. And cot A will be AB by BC. Okay, I've just listed down the ratios for angle A. Now you know that angle C is a complement of angle A. So let me also write the ratios for angle C. Now for this angle C, which is the opposite side, AB. So the sine C ratio will be AB by AC, friends. Did you notice the difference? Okay, now let me write cos C also. It is going to be, for this angle C, the adjacent side is BC. So it's BC by AC. Tan C will be the opposite by the adjacent, which is AB by BC. Now I'll start taking the reverse of sine. Okay, that will be cosec. So I'll get AC by AB. Sec C will be the reverse of this. So it's going to be AC by BC. And cot C is going to be, yes, BC by AB. Here we are, the ratios of these two angles. Now let's look for some pattern. Sine A is BC by AC. Did you also observe that cos C is also BC by AC? So, did you see this? These two are actually the same. Now, let me look at cos A. It's AB by AC. But look at this. Sine C is also AB by AC. See? These two are having the same values. Let's go ahead and see if there are any other patterns. Tan A is BC by AB. Well, just have a look. Cot C is also BC upon AB. See, these two are the same. Similarly, cosec is AC by BC. Sec is also AC by BC. And if you keep checking, friends, you will come across a very interesting relationship. And that is sine A will be equal to cos C. Is it not? We just found out. But what is the relation between angle A and C? See, if angle A plus angle C is 90, that means angle C, I can write it as 90 minus A. Is that not true? So here, I can write C as 90 minus A. And friends, this is a very, very important conclusion that we have arrived at. Sine A is always cos of 90 minus A. Okay. Similarly, look at cos A. Cos A and sine C are the same. So, can I write cos A as sine C? Yes. But again, I'm going to write C as 90 minus A, which means cos A is sine of 90 minus A. In the same way, look at this, tan A and tan C. So I can say that tan A is cot of C. I can write as 90 minus A. In the same way, friends, cosec A also. Just have a look. Cosec A over here, I can write it as, see, they both are the same. Look at this. So I can write it as sec of 90 minus A, and similarly sec A over here is the same as cosec C, which is 90 minus A. So friends, these are very, very important relationships. Also, one more that I have forgotten here is cot A equal to tan of 90 minus A. See over here, these two. Okay, so there are totally 6 relationships. Let us write it more neatly. So friends, here are the 6 relationships that we just now found out for the complementary angles. Okay, these are also very important. Let's try out one question which is based on these relations. So friends, the question is, prove that tan 48 into tan 23 into tan 42 into tan 67 degrees is equal to 1. So this is a prove that type of question. So here it's better that we start with the left hand side and prove that you get the right hand side. So let me just copy the left hand side as it is. Okay, this is my left hand side. So friends, are these some of the standard angles that you have learned over here? No, right? This is 0, 30, 45, 60 and 90. Whereas over here, you don't have these angles 48, 23, 42 and 67. We cannot find out the tangent of these angles without using a log book. You need a log book to actually find out the values of these ratios. But without using the log book, how can you solve this particular question? So let's look for a pattern. If you observe here, friends, you have 48 and you have 42 over here. So let me add these two, 48 and 42. I'm getting 90. Now when I add 48 and 23, what am I getting? 71. So that means these two are not going to be complementary angles, but these two are going to be complementary angles. Now let me go ahead and check if 23 and 67 also add up to 90. Yes, they add up to 90, which means these two angles over here are complementary. These two are complementary. So first let me regroup this expression. Let me combine the complementary angles together like this. Okay friends, this is what we need to do. If you see, tan A is cot of 90 minus A. So can I write, okay, I will just keep 48 as it is. Can I write tan 42 as cot of 90 minus 42? Yes, see which formula I am applying? Over here, this formula I am applying. Similarly, tan 23, let me keep it as it is. Now tan 67, I am going to write as cot of 90 minus 67. Again, I have applied this formula over here. Now, tan 48. Now, what is 90 minus 42? Yes, I'll get 48 again. So, I can write cot of 48 into tan 23 will be as it is. What is 90 minus 67? Again, I'll get 23. So, I'll get cot 23. See friends, now from 4 different angles, we have reduced to 2 different angles. Okay. Now, again, we need to look for some pattern. This is tan of an angle multiplied by cot of the same angle. Okay. So, what does this mean? Tan theta, if you remember, is 1 by cot theta, friends, right? So, if I bring the cot theta to the numerator, I'll get tan theta into cot theta as 1. So, tan 48 into cot 48 will also be 1. Similarly, here also the same story. Tan 23 into cot 23 will also be 1. The reason you need to write, because tan theta cot theta will be equal to 1. So 1 into 1 is 1, and that's how the left hand side is equal to the right hand side. So friends, I hope you understood how to solve this type of question. So friends, last but not the least, we come to the trigonometric identities. Well, this year we are going to study 3 trigonometric identities which are very important. The first identity is that sine square A plus cos square A is equal to 1. This is the first identity. The next identity is that 1 plus tan square A is equal to sec square A. And the third identity is that 1 plus cot square A is equal to cosec square A. So these are the three identities that are very important. So friends, let's solve a question based on trigonometric identities. You have to prove that cosec theta minus cot theta the whole square is 1 minus cos theta divided by 1 plus cos theta. So friends, whenever you have LHS equal to RHS, always go for that side which looks a little bit more complicated. So for me, LHS looks more complicated. So let me start with that. LHS is cosec theta minus cot theta the whole square. So friends, if you recall, this looks like A minus B the whole square, which is A square plus B square minus 2AB. So let me substitute this identity over here. So I'll get cosec square theta plus cot square theta minus 2 cosec theta cot theta. So friends, although this is a trigonometric question, you still need to use all types of math concepts. Okay. Now if you see, there is no cosec theta, there is no cot theta at all in the RHS, which means I have to convert this cosec and cot in terms of cos and sine, etc. Now, if you recall, what is cosec theta? It is 1 by sine theta. So let me write it over here. Let's not forget the square. What is cot theta? Again, it is nothing but cos square theta by sine square theta. Okay. Now I will write again cosec theta. I'm going to write as 1 by sine theta, cot theta as cos theta by sine theta. Okay, friends. Now let's see what happens. Now here the denominator is same and I have to add them. So I will just add the numerators. The denominator will remain sine square theta minus 2 into 1 into cos theta, that is 2 cos theta. Remember, these are all getting multiplied, so sine theta into sine theta will give me sine square theta. Did you observe again the denominators are same, so I can directly subtract. So I'll get 1 plus cos square theta minus 2 cos theta. Again, what does this look like? If you observe, this looks like the same identity over here. See, A minus B the whole square, the same identity where A is 1, B is going to be cos theta. So I can write this as 1 minus cos theta the whole square divided by sine square theta. Okay, friends? Now, I can also write this as cos theta minus 1, remember. But what is there on this RHS? It is 1 minus cos theta. That's why I have chosen 1 minus cos theta and not cos theta minus 1. Okay. Now friends, again, I need 1 plus cos theta in the denominator, whereas I am having sine square theta. So let me try to change the denominator also. If you recall this identity, sine square A plus cos square A is 1, which means what is sine square A? It is 1 minus cos square A. So I can write this sine square theta as 1 minus cos square theta. So let me do that. Now friends, this I can write as 1 minus cos theta into 1 plus cos theta. Which identity I have used? Yes, A square minus B square is A plus B into A minus B. Okay. Now this 1 minus cos theta is common. So I can cancel one such term. So what remains is 1 minus cos theta by 1 plus cos theta, which is equal to my right hand side. See friends, they both are the same. So this is how you can prove that questions where some of the trigonometric identities will be involved. So friends, with this we are ending the explanation for the trigonometric chapter. I hope that you found this video useful. If so, please do like and share the video. Consider subscribing to Enjoy Math and please leave your comments in the comment section below. So till we meet again in the next video, take care.